Hello, in this video we're going to continue Loki, and so in the last video we just bootstrapped our parser and wrote a small part of it to parse and assign operation. There was a test failure, but I did fix that. That wasn't a test failure. That was a compile issue that I fixed by. The problem was in this line here, down here, and I did fix it with cloning. Anything else? And also I simplified the structure of our types. So we have only an expression type and a decal type, but actually it's a bit more complicated, so probably we also need a struct, not necessarily a struct. So what we need, so now our decals always have names, but sometimes, for example, imagine it just an if expression. It's not going to be bounded to a value, so it's not the decal. So there is going to be something called a statement, which is an enum. Okay. Statement, which is an enum, and this statement is either a decal with a decal inside, or a if, or a for, maybe. These can be, a statement can be something like these, and is there a naked function call? So fn call, function call. This can be also a statement. That's one way, but the other way, which flattens everything, I don't know if this is a good thing to do. I'm just gonna go with that. I'm just gonna say that everything is a declaration, but sometimes declarations have no name, so it's an optional of string. And now this would be a sum of this, and this would be sum of this. So we got this. So now what is the problem with this? So we have the decals. So now how we are doing the parsing of the decals? Let me full screen this. Maybe make myself a bit smaller, like this. Okay. So what is the problem? What is the algorithm, or basically the flow we are using? There's not a special algorithm. So if we find an identifier, if there is no current declaration, we are going to create a new declaration, use the name of that identifier, and the expression is nil. So we also need another thing. For each declaration, we are going to have a type, and there is going to be an enum for types, right? There are int, float 32, float 64, string, etc., right? So there is types as well, and that is an optional as well. Option of types. So I'm gonna say derive clone debug equal and partial equal. So the declaration type for now is none. I don't know the type. right? But for example, in here, when we reach the assign operator, our next token, I know our next token. So so in each declaration, so for example, in here, I know that our current declaration, current deco as mute, unwrap, I know that the type is now types int, and this is going to be a sum. So basically this is a really naive way of doing type inference. And type in here is going to be sum of types int. I also need to import that from here to types. So this should still pass, right? Yes. Nice. Okay, I don't know why this shortcut didn't work. So so what I need to do now is to make this a bit better, I guess. So let's do something a bit more hard. So let's say that my next token is going to be a token type. I'm gonna say, let's go for the hard one. Let's go, for example, for an if. What if I get a, so basically what if I have something like this, x equals if true something. What if I have this? Huh? What would happen? Yes. For example, if the next one is, I mean, for every token we can infer that, right? So for example, if we have an if, what we need to do is, I can do a for loop, or I can do some stuff. So I'm gonna say condition is going to be next token, not next token. So next token was, so I'm gonna say tokens, so sorry, tokens dot either dot nth I plus 1 unwrap, not unwrap. So I'm gonna say match on this. If this is sum of a token, sum of condition token, what I'm going to do is, what is this? Okay, so if this is a condition token, what I'm going to do, I'm gonna make the condition should be also kind of declaration. It's not necessarily a declaration, right? It's an expression. So I'm gonna say condition token dot type and value condition token. Let's have a helper function in here as expert, passing a token will return an expression, right? So mapping a token, okay, so I'm gonna say if token dot type equals token type, and I'm gonna say, for example int, not int, number. I'm just gonna return expression int, and I'm also gonna convert this like this. So this is going to be token as ref unwrap parse unwrap. There are lots of unwrap which I need to fix, but some other time. Else I'm going to panic. Cannot turn token into expression. Okay. And actually I can now do this. So I can now say as expression next token. Oh, okay. Okay, cool. Should do the same thing for this as well. So I should do the same thing. So our condition, so what is our condition? If condition token dot type is, for example, token type, let's say, so what can be inside a condition? Huh? What can be inside this condition? Something that is a boolean, right? So something that is a boolean, it's either an identifier, a boolean itself, or any kind of expression, right? You know what, this is not a good, okay, sorry, this is not a good way to do this. So as expression should get a vector of token references, I think, and do this for them. So this is going to be if tokens, if tokens dot len is 1, do this. Token equals tokens 0. Okay, so what we need to do at each time is so when we reach a number, we should just do this. I mean, we should do this simpler. So what I want to do, so for example in this case, when we reach in here, I want to read all tokens, right? I want to read all tokens until I reach the semicolon. That is basically my expression. Oh, what if there was internal? That is hard to parse. Because what if there was internal semicolons? Basically, how I can understand that? I think there is no general way to do this. I should do this like the thing I'm doing right now for each expression. So I mean, there aren't limited number of expressions now out there, right? So I can say, if I go into the tokenizer, I can see that I either have a number, I either have a value in there, right, a simple small value, or a function, either a function call, or an if expression, or there is no for loops. In that case, that is 4, I think, scenarios. So if is one of them. So if we reach an if, my condition, So yes, this is actually okay. So my condition is if the token type of the condition if there is no condition, I'm gonna say panic if needs a condition, right? Maybe we should have a better error handling system, but for now this would suffice. Let me check something. Okay, sorry for the disruption. So okay, so if there is a condition token, what I want to do okay, this is not necessarily the condition token. This is not necessarily the condition token because you know what, I don't like this. I don't like this if, because I'm iterating over an iterator. It's really hard for me to to go forward and backward. I mean, it's a bit scary for me when I have this. So what I want to do is to say for I in tokens len from 0, right? So I'm gonna say token is, or I'm gonna say current token is tokens I. This cannot find, okay, because it's a current token. Current token, and this is also current token. Okay, cool. So it's not going to be this much hard. I'm gonna say yes. This is because it helps me with this optional thing helps us. It saves us from some crashes that we actually move beyond a slice boundary. So but in here what I want to do is so I'm gonna say this has this, and I'm gonna say start of condition token is I plus 1. This is I plus 2 probably, because we are in an assign, remember? So this is I plus 2, and let end of condition token, end of condition, I'm gonna say is for now -1. This is going to be also a U size, so it should be 0. So how I should find so I'm gonna say for I plus 2, which is the start point, for j in I plus 2 until tokens.len, what I want to do is to say, so what I want to do, so I'm inside, remember I'm inside an if, right? Actually I don't need a for loop for this. I'm just gonna say, so after the condition there should be, after the condition a start, okay, a start of the condition. Okay, I'm finding the condition. Okay, so for condition starts from after the if until the curly bracket open, right? So what I will do is I will look if tokens j equals, if token j dot type equals token type curly bracket open what I'm gonna do is say end of condition is here and break, right? This is what I want to do. So finds end of condition, and this is actually j minus 1. So we find a condition in here, right? So this is a condition. We want the expression as well. How we should do this matching stuff? There, I can use a stack. Since we are looking only for a curly bracket close, I can do a increment and decrement. So, and every time I see an opening and then see a closing, I'm gonna increment for openings and decrement for closing, and when I reach a decrement that makes my stack -1, my number -1, that's my closing point, right? So let's start off, then block is end of condition +1. So now now tokens j dot type, if this is token type and it's a curly bracket open, I'm gonna say let bracket counter still open is 1, because we already are counting from this, right? So this is a 1. Okay, so if we reach another open, I'm gonna say curly, okay, so let me just curly still open plus equals 1. Oh, this is it. I'm missing an if, else if tokens j type token type curly bracket close cu still open minus equals 1. So if curly is still open equals 0, it means that let end of then block. End of then block equals j. So we also find, I'm basically finding blocks of code. So then it would be, so if tokens j plus 1, j plus 2, not j plus 2, sorry, end of then block plus 2 equals dot type if end of then block tokens of len token type Okay, if we have an else, we also need to do this almost the same thing as this, right? Yes. So let's start off else block is end of then block plus 2 end of else block, which is a u size 0 for now, start of else block I do the same thing. So I found all necessary pieces for an if in here. Took a lot of code, but now what is this? Why we have no error in here? It says expected this. Okay. We still have not emitted. Okay, that was actually okay. We have a problem here. I was just going and didn't consider that we are in a match for oh come on, I ruined it. So where is the start of this if? Okay, start of okay, so finds start and end of condition. Then we have this block of code finds start and end of then block code, and finally if we have else finds start and end of else block code. So we now have these, right? None of these are mutable. Cool. So when I'm doing the assign, when I'm doing an assign operation, I'm gonna just peek into the next item in my tokens. If it's a number, I'm just gonna assign it. I'm just gonna say, okay, I have this expression which is just an int. If the next token is going to be a if, I'm gonna find the condition, because I need a condition, and I also check if end of condition equals 0, it means I didn't find the end of it. It's a syntax error, so I'm gonna panic, because panic cannot find end of if condition, end token of if condition. Same goes for this. Okay, so we find everything. Now what data structure we should use? So we know that we have this this expression. So it's going to have an if inside it. But what is an if? An if has condition, which is an expression, right? Cannot have a recursive data thing because expression depends on if and if depends on expression, so I cannot basically do this. Okay, so if has a condition which is an expression. It also has a then block, which is going to be, it's not necessarily an expression anymore. I'm going to rename this to a statement. No, let it be expression. There is a then, which is a block. So I started with a really hard one, but we are making so many things now. So a then also has, then is also an expression. There is an option, which maybe there is an else block as well. So what is a block? Cool. So we have a block. What is a block? A block is, I think, a block should be just a vector of expressions. Expression is the most high level type we have, right? No, it's a declaration. So I'm going to say declaration. A block is nothing but also a vector of declarations. I mean, the high level type we have is this. Let me just do this a bit better. Put these in at top, our types. So at first we have types, really simple. Then we have declarations. Let me just write a simple document for this. So decal is everything done in Loki. Anything is a declaration, either with a name assigned to it or not. Then we have expressions. So now in here, what I want to do for condition, so we have the start and end, right? So now we should call as expression, pass it the tokens from, oh my god. So I'm gonna call as expression, passing the tokens. I'm gonna pass from start of condition until end of condition, right? We will okay, so it will create a slice. Can I do to back? And expected this, found this. So it's gonna copy everything. If I do this and this, I'm gonna do clone, and I'm gonna do clone. Okay, so now as expression, this should give me the condition expression. Same code is there for then expression, start of then block, end of then block, and I have also the same code in here for else expression. Oh my god, else expression, start of else block, end of else block. So, and also if you take a look at this, this has a hard task to do. Let's imagine this all works. I'm gonna say this is going to be a sum of these. Now, after this, we have basically built the if. Now that we have created the if, where is the if type? I just created one. Yes. Let's create a, so let's I'm gonna in here say current deco dot as mute dot unwrap dot expression equals a expression if condition is condition expression, then block is then expression, else block is else expression. It's what is else? Option of box. I'm gonna do it other way around. So I'm gonna do a box of option. Okay. So then we create this. We put this put this current echo thing, and what we do for the current echo when we push it, so when we reach a semicolon, this is not necessarily okay, because this will not work for these hard parts. So for example, in this case, right, when we have this if else thing, can I reassign I in here? If I can, it might work. Okay, so when I create in here, what I will do is I equals end of if is, of course, end of then block plus 1 right plus 1 if else expression that is sum end of if becomes end of end of else block plus 1. This will point to the curly bracket ending those. End of if. Oh my god. Oh, so I was moving basically this, and that was correct because I was moving this to deco. Okay, so I is now reassigned, and you know what, let's just write a test and test this. It was a long thing, but I think we did, I think, good. Let's write one test. Let me just copy this. I'm gonna need most of this, and collapse this. I want this to be collapsed. So it's a test. Function parse assign if. Okay, so tokens is ident x assign. Okay, so this is going, okay, this is going to be if keyword, there is no value, then after if I'm gonna say just a true keyword. After that I'm gonna say type token type curly bracket open, no value, token type this is not necessarily to be valid, so I'm just gonna say true. This is not necessarily means that it should have meaning, and actually this has meanings. And curly bracket close, the value is none. Okay, so if I parse this, this should give me a deco with this name. The type is going to be type if. The type is going to be none, right? And the expression is going to be an if has a condition, make this public. This is not going to work because I did not write this part still. So if, let's say, number, do this, I should also say if token type is token type boolean or true, or token type false. I'm gonna say return expression boolean and token type true. So hopefully this works now. So I have this condition. There is this then block, which is also a box of a block. So a block is block. Okay. Oh, that was hard. So this is basically what we should generate if we pass these tokens. Run. We should fail, right? Because of cannot turn token into an expression. Okay, this happened in here. So let's see. Let's do a print line for tokens. And okay, tokens are empty. There's a problem with this ranging we are doing, but I'm a bit tired to do them. It's probably just off by one because we have tokens. I mean, our condition and stuff are just one, and it's probably off by one problem. But I'm a bit tired now, and I think I'm gonna fix these in offline and not on stream, and hopefully make the parser be a respectful parser, and then I'm gonna just record another one to tell you how we did it. I don't know, maybe I do it online as well, I don't know. But anyways, this is the end of this video. If you like this content, if you want me to do more of this stuff, please like and subscribe and tell me, of course. And you can always contact me using mail, GitHub, and comments. Thank you, and until the next video, goodbye.